Hello friends, welcome to Electronic Circuit Hub. So today we are going to learn about how to change the transistor beta value in LTSpice. So what is transistor beta? Transistor beta is nothing but it is a current gain. Okay. So I will change the different value of beta for this BC846B and I'll show you what is the impact in output. Let me say, if you know the relation between IB and IC, so the collector current IC is given by beta times of IB in linear region. Okay, so if you change the beta value, you will change the collector current, since collector current is given by beta times of IB. Okay, so many a times you are not able to change the beta value, different beta value for your application in LTSpice. So in this video I'm going to show you about how will you change the beta value for this particular transistor BC846. Okay, so I'll run the simulation and I'll show you the what happens to collector current if you change the beta value. Okay, so if you see here, this is a basically a simple circuit which you can see the 5 volt is VB, then I have used R3 as 330k, then this Q1 is BC846B, and you can see this resistor R1 is 470 ohm. Okay, so let me use calculator here. Okay, just for simple calculation, right? If you 12 divide by let's say the saturation voltage is 0.2, divide by 470, that means you can see with this configuration your maximum collector current is 25 milliampere. You can get the maximum collector current 25 milliampere. Okay, now you can also calculate the base current, which is given by 5 volt minus 0.7. So let me write it, 5 volt minus 0.7. This will give you 4.3 divided by 330k. Then you will see here you have the base current is 13 microampere, right? Did you understood how I have calculated the base current and how I have calculated the collector current? It's a very simple calculation. You to calculate the base current, you have to apply KVL in this loop, 5 volt minus 0.7 divided by 330k, and to calculate the collector current you have to apply the KVL in this loop, 12 volt minus 0.2 divided by 470. So you have seen your base current is 13 microampere now, and your collector current is maximum you can get 25 milliampere, right? Around 25 milliampere. Okay, let us run the simulation and let us see the behavior here. Okay, now we don't know, let us say we don't know the value of beta here, so let's directly run the simulation and see the result, right? So you see your base current is, I'm not sure, let me apply the cursor, and you see here you see here how much your base current is 13.1 milliampere. And what was your calculated value, guys? Your calculated value was also 13 microampere. You can see your simulation result is 13.1 microampere. Now let me show you this, the collector current. And can you see the collector current, guys? The collector current is 4.39 milliampere. Okay, so what you have, the collector current is 4.39 milliampere. That means you have to multiply by 1000. So this will become the microampere, that means that much microampere, divide by you have 13 microampere, right? 13 microampere. So I wanted here to calculate the beta value. It is coming around 337, right? 337. So your beta value should be 337 for this configuration. And let me show you. So to see the beta value, what is the beta value? You have to right click on this transistor Q1, just right click on the Q1 and you have to go at this pick new transistor, go at this transistor, and you see here your BC846C, and you can see here the property for this spice model for this BC846CB. So I'll just copy this, and I'll close this, and I'll open the spice directive here. This is spice directive, right? .op. And what I'll do is I paste this. Okay, so I paste this, and let me show you the beta factor here. Okay, how much is the beta factor and how much you have calculated here? It's coming around 337 beta. Your beta was 337 when you calculated the, when you have seen the IC current and IB current, and you can see here your beta factor is 324, which is very closer, guys. Now let me change this beta value to 400, and let me show you the impact here. Okay, so I have changed the beta value to 4. Let me put it somewhere down. Okay, so let me run the simulation again, guys. It's not visible, so let me do it here. And how I can make this let me put somewhere else, right? Let me put here, guys, so that you can see. Okay, so let me run the simulation again, and let me show you the result. Now this time your collector current is 5.4 milliampere, and if you calculate your collector current, that your base current was 30 microampere, divide by the multiply by 400, your beta current, beta you see here, you can see here, guys, the beta factor. Okay, you can see BF here. This is the BF, which is 400. Let me calculate the collector current. You see 5.2 milliampere, and you can see here it's very closer, 5.36 milliampere. Okay, now what I'll do is I'll change the beta value to this beta factor, you can see here, to 500. Let me change the beta factor here, 500, guys. So then I'll run the simulation again, and now you can see the result. It is coming around 6.54 milliampere, right? So now your 30 microampere multiply by 500, what you'll get